Yes, ma'am.
Okay. I'm so sorry I was late. I have come to the university and I just reached university. So, uh, I think we had done the bend tendons. Just let me know, okay? Pre-stress.
Ma'am, our university already open or what?
Hello?
Ma'am, university is open or not?
No, it's for only if we have some work or some faculties, etc. But not for students. But university is open, yeah. For other
Okay. What about
research
student?
related or admissions, these things, etc. Other works. For official works, it is open.
Oh,
Not for students, but classes are for online.
okay.
Okay.
What about student, ma'am?
Uh
Expected
huh.
date for offline class. Offline
Hello.
class. What about student, ma'am?
Offline class.
What
That
about?
though we
Yes,
cannot
ma'am.
say now because the
Okay.
government is deciding, right? I don't think this time you will have offline class this year. I don't know. Okay,
Okay.
from I think according to me, this year you might
Okay.
have all online classes till this semester until
Okay.
further
Thank you.
notice from the government comes.
Yes, ma'am.
Okay. We were. Did we do tendons with parabolic profile? Did we do with parabolic? No, ma'am. Okay, no, ma'am. Parabolic profile we have not done, na. So, but we had done with bend tendons. Yes or no? Yes, 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 yes. Okay. That means today we'll start with you the bend tendons with parabolic profile. Okay. Let me share my screen then. Okay. So today we'll be talking about the tendons with parabolic profile. So you can see here, if I show you this figure here, wait, let me remove this. Okay. So you can see here in this figure, what is there? A pre-stressed beam. This is a pre-stressed beam which is carrying an external load, which is your W per unit run. Okay. And what is happening? This is W per unit run, and the tendon which is provided, it is bent in, and its shape is how it is. Its shape is parabolic. Earlier we had done a problem on the bent tendons, and your tendons were in this way. Okay, so now what we are going to do is we are going to talk about the tendons which will have a parabolic profile. You will have some of the tendons which will have a parabolic profile. Okay, so in that case, when you, because this kind of earlier, previously when we had talked about this kind of triangular profile band tendons, they used to give an upward thrust in this way. That was how much? 2p sine theta, right? So in the similar way, your bend tendon is going to provide an upward thrust. Okay, but since this is a parabolic profile, what will happen here? The tendon is a parabolic profile. When the cable is provided with the parabolic profile here, it will exert a uniform upward pressure, which we can say to be WC per unit run. Okay, so that means this parabolic profile, throughout the beam and throughout its profile, it is going to provide an upward force in this way per unit run. It is going to provide this way the loads reaction. That means, so what will happen? This, and due to this load, what is happening? This load is acting per unit run, the external load W. So this WC, this upward pressures which are there, they are going to resist this downward loads. This W which is acting per unit run, they are going to be resisted by your this WC, which is the then reaction given by your this parabolic profile. Okay, and so this is going to counterbalance the loads. Okay, you can see in this figure also. If you see this figure, these are your pressures which is given by your this parabolic profile, and when you give a pull to this tendon, what happens? You're giving tension to the tendon, and then when you release, these are the pre-stressing forces which will be developed. This one is your pre-stressing force which is developed, right? So we can consider this to be WC per unit run, which are the loads transmitted to the beam. So you can say this is your downward loads, this one W per unit run. So they are acting on the tendon in this way, and the tendon is also due to this pre-stressing force. When you release the anchorage and this parabolic profile, tendons are also going to give upward thrust in this way. So we have to know now what is this upward pressure. What is the value of this upward pressure which your tendon is giving back to your downward pressures? Okay, so what happened? We know in a parabolic profile, what we know that in the theory of cables carrying uniformly distributed load on the whole span, what happens? This is your horizontal reaction at each end of the cable. Here, whenever you have a cable, there is a reaction at the horizontal, okay, which is given by Px is equal to Wc L square by 8h. Okay, where h is your dip of the cable center below the ends of the cable. This one, this is your h, which is known as your dip. This portion, how much depth or dip it is. Wait 1 minute. Give me a second. Hello. Okay, where we were, yeah, Px, we this in the cables, when we know that the upward reactions are given by Px is equal to Wc L square by 8h, which is your h is your dip, this dip. Okay, now we can yeah, we can make the approximation to be Px is equal to P, this pre-stressing force which we are giving. It is nothing but they will be same equal, because this is also having a parabolic profile, and this is also acting like a cable, you can say. So in cable we know the reaction, horizontal reaction which comes, it is Wc, that means WL square by 8h. So we can write that P, our pre-stressing force, is also equal to WL square by 8h. Okay, so now we know that whenever we have a parabolic profile, what happens? Your upward thrust, which the tendon will be providing to the downward loads, is how much? You are going to calculate it by WL square by 8h. Okay, from this equation you can find out what is your W. When you don't know what is your WC, that WC was what? WC was the upward thrust, this one, which your parabolic profile is going to provide to the downward loads. So what happens is that now you can calculate your WC. What is your WC? 8 pH by L square here now. So what will happen? Hence, a parabolic tendon carrying a tension P will provide an upward uniformly distributed load or pressure, WC 8pH by L square. So, in parabolic profiles, you are going to find out, or you know, what is your upward thrust given by the parabolic profile per unit run is how much? 8pH by L square. Okay. So now if we go and solve a problem here, note down this question fast. This is a figure given to you, a pre-stressed concrete beam which is provided with a bend tendon of a parabolic profile. Okay, if the total external load on the beam is 35 kilonewton per meter on the whole span, calculate the extreme stresses for the midspan section. That means at the center we have to calculate the stresses. Okay, the external stresses are provided to us, which is 35 kilonewton per meter. We have our pre-stressing force P is 1000 kilonewton provided. Also the dip is mentioned to us, which is 100 mm. Okay, span is also given to us, provided here. Span is 6 meter. A 6-meter beam with a tendon having a dip of 100 mm and a pre-stressing force which is provided to be 1000 kilonewton is given to you. So what we have to do now, we have to calculate the stresses at the top and at the bottom of the beam. Okay, so can you solve this? Can you solve this here now? Just try this once and tell me the answer. Anyone? Can you solve? Just try this simple, the thing which I had just told you now about the parabolic profile, that it provides an upward thrust of how much? That much. You have to calculate 8pH by L square. So now after that you can easily find out what are your stresses. You know what is your downward pressure, upward pressure, everything. Just roughly try to calculate once and just tell me what are your extreme top fiber stresses and the bottom fiber stresses. And I let me tell you one thing, that the previously we had done with the bend tendons, like with the parabolic profile. Okay, triangular parabolic profile. So previously we had done what? The bend tendons with parabolic, no, sorry, triangular profile, as well as now we are doing the parabolic profile. With the parabolic profile, how to calculate the stresses. So basically the things which we're doing now is the load balancing method. Okay, in the, I think in the first class maybe I told you that if I go to the annotations here, in the first class I told you that there are three methods of finding out or calculating the stresses in a pre-stressed concrete beam. The first method was what? Stress concept method. The next was your this thing, the load balancing method. Load balancing method. And the third one was your C line method, or you can say strength concept method, or you can say it to be P line method. Also, you can say it to be P line, C line, strength concept method. Okay, or thrust line method, or you can say it to be pressure line method. Okay, so in the first classes, the stresses which we were calculating in the pre-stressed concrete beams were on this method. Okay, the stress concept method. This one, the first one. Okay, it's not there. This one, the stress concept method. And now when we are solving some problems which have a kind of load balancing thing, like when you have a bend tendon you are giving an upward thrust, your tendon will give an upward thrust to the downward loads. Okay, so this upward pressure, this upward thrust is going to balance your this downward load. Okay, somewhat they're trying to balance. So this method is known as your this calculation, this type of calculations or solving or finding out the the stresses is nothing but your load balancing method. Okay, that means we're trying to balance the load. Your downward load is trying to be balanced with the upward pressures. Like suppose if this is your 10 kilonewton of load, downward load, and your upward thrust is suppose a 9 kilonewton, so it is trying to ultimately balance, but it has now how much left over 1 kilonewton of load. Okay, so this is trying to balance. So this methods which we are solving, that is the downward load, upward loads, upward thrusts are generated, outward thrusts, we are giving upward thrusts to the this beam. So these methods are called what? These methods are your load balancing method. Okay, understood? We have not gone till now to this C line method or strain concept method. We have done the stress concept method, which was the first questions, like only to find out the stresses. You used to calculate the stress at the direct stress, that means the stress which is uniformly distributed, the stress which are due to the moment which are developed due to the loads, external loads, whether it be dead load, live load, etc. So and also if there is an eccentricity due to that, with the moment which is generated or the moment which is developed, due to that some stresses were developed. So we used to calculate directly the stresses, that means the whether it be the direct stress or the stress due to eccentricity, stress due to your movement. So those were your stress concept method. And now which we are doing, that is there are some tendons like bend tendons, etc., which are giving an upward thrust to the downward loads just to counterbalance. So these methods are known as your load balancing method. So we are doing the second method, which is load balancing method. Okay, anybody answer this question? Did you get what is your top stress fiber and the bottom stress fiber? Anyone? Womnak, Shimti, Subolemba, Nanzia, Charlie, Saptadeep, Stephanie. Did you try? Trying, ma'am. Okay. Itna time. Just you have to find out this thing. That is your upward thrust with what your this particular band tendon with the parabolic profile is giving an upward thrust. So what is that upward thrust? If you know, then you can counterbalance this too. The downward load is given 35 minus your this 8 pH by L square. Till then I can do one thing, I can take the attendance. Mm, Stephanie Bang, roll number one.
Present, ma'am. Roll number one.
Two, four, five, six.
Present, ma'am. Number 5. Present, ma'am.
Okay, five, six,
5.
Ma'am.
six, seven, eight,
Yes, ma'am. Present.
Yeah, you please tell your enrollments. Okay, 8.
Present, miss. Yes, roll number 8.
Yeah, 9. Enrollment 9. 10. 11.
Roll number 10.
11. 12.
Roll number 10.
Yeah, 4 to 11. 12. 14. 12. Okay. Okay, present 12. 14. 15. 17.
Yes, ma'am, 17.
18.
Yes, ma'am. 18. 18, yes, ma'am.
Okay, 19. 20. 21. 23. 24. 25. 26. 27.
26 present.
Okay, 26 present. 27. 30.
Yes, ma'am. 30.
Okay. Ma'am, no pen, copy not in home. Bomnak. What, ma'am, no pen, copy not in home?
I'm not in home now.
Oh, you're not in your home now. Okay, I'll show you
Yes, ma'am.
I'll show you the solution. It is very simple. Okay. What is happening to my?
Yeah, ma'am.
Oh, okay. This is your solution. Okay. See what is done here. Area is, we know area, we know our section modulus also we know. So you know your this one. Area is given. Why my highlighter is not working? This one area Z, you know, H, you know, it is given to you here 0.1 meter. Span is given to you. Okay, so we have to calculate what? We have to find out the upward thrust which is given by your this parabolic profile. So what is that? We know, I already told you that it is 8 pH by L square. Okay, so P, you know, what is a P? 1000 kilonewton. H is how much? H is your this 0.1 meter. This one, and your span is 6. So you get your upward thrust, which is your 22.2 kilonewton per meter. Now your what is the net downward load which is acting? You had 35 kilonewton downward load. So 35 minus your this 22.2 will give you your some remaining load. Okay, the thrust here it was 35 and here it is 22.2. So if you subtract this two, what will happen? You have a now the load which is acting downward is how much? 12.78 kilonewton per meter. This has compensated. That means tried to balance to some extent 35 minus 22.2. So this much is left now 12.78. So that means this is acting now, and due to this downward load, what will happen? You will have a moment developed, which is WL square by 8. This is a UDL. So WL square by 8, L, you know. This is your moment. Now, once you know your moment, you also know your section modulus Z. You can easily find out your stresses. Now, you tell me what is your extreme top fiber stress and the bottom fiber stresses. 24 is present. Okay, 31, 32. Give me your attendance. 31, 32, 34, 36,
36 present, ma'am.
37,
34 present.
34 present, 38, 39, 42. Hmm? Please
And
give me
yes,
your
ma'am.
enrollments. Okay. 009 Charming.
39, yes, ma'am.
Yeah. 39
Yes, ma'am.
present.
39.
38, 37, 42, 43,
Present, ma'am. 43.
45, 45, 46, 47, 48,
Present,
40,
ma'am. 48.
49. Okay, 49.
49 present, ma'am.
Mm-hmm. 9 present. 50,
Present, ma'am. 50.
51, 50, yeah, 50 present.
51 present.
51,
51 present.
52, 54,
Yes, ma'am.
55, 56, 57,
Present, ma'am. 57.
58, 59, 60,
Present, ma'am.
61.
60.
Okay, 61,
Present, ma'am.
63.
61.
Okay, 61,
Yes, ma'am.
63.
63.
Okay, 99.
Yes, ma'am. 60.
Yeah,
Yes,
99.
ma'am. 99.
Okay,
Yes, ma'am.
101.
101, ma'am.
Okay, 104, 106, 108, 109, 111, 113, 114, 118, 120.
118, ma'am.
Huh?
Present, ma'am.
118.
Yes, ma'am.
118. 120.
Present, ma'am.
120. Hello?
120 present.
120 present. 121. 124. 124. 1 Shimti. He was there. 124. Okay, 133.
Present, ma'am. 133.
Okay, 134.
34 present, ma'am.
136.
136 present, ma'am.
Okay, 143. 144. 145.
145 present, ma'am.
Okay, 148. 149. 150. 151. You can comment in the chat box, okay, if you have missed. 104 I can see in the comment section. 54 is given. 108 is present. 009 is present given. Okay, done. I'll just call out the absentees. Those who are absent, enrollment 2, absent, 4 absent, 7 absent, 11 absent, 14 absent, 15 absent, 19 absent. Hello, 149 present. So absent is how who? 14, 15, 19, 20, 21, 23 absent, 25 absent, 27 absent, 31 absent, 32 absent, 37, 38 absent, 42 absent, 45, 46 absent, 52 absent, 55 absent, 56 absent, 58 absent, 59 absent, 106 absent, 109, 111, 113, 114 absent, 143, 144 absent, 148 absent, 150 absent, 151 absent. Okay. Okay. Did you get the extreme top fiber stress and the bottom fiber stresses? Okay. Shimti. How much? Top fiber is 6.57. Okay. Bottom is, yeah. And others? Did you get what you have got others? Our meeting will end in 5 minutes. How much did you get others? Okay, whatever. Shimti is correct. This is, you can see here, your extreme top fiber stress is your 6.57. bottom is 1.77 Newton per mm square. Now we'll talk about load balancing method. Actually, all the things which we were doing in the previous classes, these are your nothing but load balancing method. Okay, and now properly, if we try to discuss load balancing method, is sometimes what happens, we try to neutralize the loads. Okay, like suppose neutralize completely. Like suppose this is 10 kilonewton, if I say you, and you want to completely neutralize this downward load. So what you're going to do, you are going to give an upward thrust of 10 kilonewtons, such that your this load which is coming on the beam is going to get over. Okay, because this is resisted by the 10 kilonewton of the same value. Okay, so same load is given back and so it gets neutralized, right? So load balancing method is, in sometimes in load balancing method what we do, we try to completely neutralize, and in that case when we try to completely neutralize, what will happen, we will have to design it in such a way so that this upward thrust comes to be 10 kilonewton. Because yes or no, because we used to calculate this upward thrust in case of load balancing methods, we used to calculate how much upward thrust is your tendons going to give back, right? So when we want to neutralize completely, so we will have to ensure that this upward thrust comes to be 10 kilonewton, because you have an downward load of 10 kilonewton and we want our upward thrust also to be 10 kilonewton. In that case, what we'll do, we will have to design our dip. That means either the dip, that is here, suppose this is a parabolic profile, this dip you have to measure. In that case, what we'll do, we'll equate this to, okay, that means the downward load is equal to the upward load, and in that case we know our downward load, some upward downward load will have some value, like suppose 10 kilonewton, and your downward load will be what, in case of your parabolic profile, if you say, it is how much, your upward load is 8 ph by L square, so 8 ph by L square, this is equal to 10. We are going to equate this to, such that these two are equal, and if it is a triangular shaped bend tendon, so how we are going to equalize this, like it should be, suppose here also it is 10, your downward load, so 10 is equal to your this 2p sine theta, 2p sine theta, and from that 2p sine theta you can find out your either the pressure, that means the pre-stressing force, because here suppose we equate this to 8 ph by L square is equal to 10. If we equate this to, that means this is the downward load and this is the upward load given by your parabolic profile, and we want to completely neutralize, so what we are doing, we are equating this to, now if we know the pre-stressing force, this one, and a span of the beam on which the load is falling, we know, then we can easily find out our h from this expression. 8 ph by L square is equal to 10. From here we can easily calculate our dip, which is your h. So that means this will give us, or this will let us know how much dip you must provide, how much your dip of the cable you must provide, such that it will give 10 kilonewton. Okay, so we will find out how much dip is to be provided such that your these two loads are neutralizing. And also suppose sometimes you may be given the dip, that you restrict your dip to be suppose 100 mm again, that means 0.1 meter. If you have to restrict your dip, suppose you cannot give much dip to the tendon, then you are restricted with this, then you are asked that how much pre-stressing force we will want to know how much pre-stressing force we need to provide, such that we neutralize this downward 10 kilonewton. So 8 ph by L square equal to 10 if we do, and we know our dip because it is restricted, so dip and length span we know, so pre-stressing force nikal jayega. You can calculate your pre-stressing force. So in this way, in a load balancing method, we try to neutralize. When we try to neutralize, we will equate these two. That means the downward and the upward thrust we are going to equate. And these things which we were doing, all those bend tendons, then again the parabolic profile tendons, we were doing this kind of bend tendons, etc. These are nothing